This video is going to work through the solution to problem 8 from the review exercises. So in problem 8, suppose that the number of cars towed into a repair shop per day follows a Poisson distribution, and that the average number of cars towed in per day is 6.5. And by a day, I mean a 24-hour period. I'm going to let X be the time from midnight until the first car of the day is towed in. So if we're measuring time in hours, sort of our lambda is going to be 6.5 per 24 hours. The time until the first event in a distribution Poisson process, remember, has an exponential distribution. And so because it has an exponential distribution, our theta value is 1 over our lambda. So if we're measuring time in hours, theta is equal to 24 over 6.5. And so that is going to be our distribution. So I guess here's the answer to A. Okay. Now B asks, what is the probability that the first car is towed in before the repair shop opens at 8 o'clock? So this would mean that we're looking for the probability, measuring in hours, that X is less than 8 hours. And we can find this by integrating, saying, okay, the probability that's less than hours is the integral from 0 to 8 hours of our exponential distribution's probability density function. So that would be our 1 over theta, which would be 6.5 over 24, times e to the minus 1 over theta x. So that would be minus 6.5 over 24 times x dx. And when I evaluate this, I would get a probability of 0.8854 if I round to 2 decimal places. So just need to sort of go through and do the integration, evaluate the limits, and there we have it. Okay. Question part C says to let y be the time from midnight until the second car is towed in, and we want to know the distribution of y. So remember, a gamma distribution gives us the time until the alpha event occurs, and so here if we choose alpha equals 2 and our same theta is 24 divided by 6.5, then y has a gamma distribution. Part D asks us to find the probability that the second car of the day is towed in before the repair shop opens. So I could think about integrating from 0 to 8 the gamma distribution probability density function, which is going to be 1 over gamma of 1, which is just 1. I'm sorry, 1 over gamma of 2, which is just 1, times 24 over 6.5 to the alpha, so that's 2, times y e to the minus 6.5y over 24 dy. This should be a 24, not a 25. And if I go through and do this, because I've got this y times the expected value of y kind of piece, I'm going to need to use integration by parts to actually do that integration. But if I go through and do it, I come out with an answer of 0.6372. Now, I do want to mention that both of these could also be solved with a Poisson distribution. If I wanted to, I could say, okay, well, the probability that x is less than 8 is the same as the probability that I would have no events in 8 hours. So if I used lambda equal to the mean number per 8 hours, that would be 6.5 over 3 would be the mean number that would occur in 3 hours. And I could use my Poisson to find the probability that I'd have no events. And then I can say, okay, well, the probability that I have that the time is less than 8 is 1 minus the probability that I have no events in 8 hours. So I can take 1 minus that and it'd come out with the same sort of answer. Similarly, I could use, and so I guess just to kind of flesh that out, this would mean that I'd be taking like 1 minus e to the minus 6.5 over 3, and you can see it's going to come out to the same value. So you might have approached it differently using the Poisson instead of using the exponential distribution. You'll come out with the same answer, but keep in mind that x, the time until the first car gets towed in, does have an exponential distribution, not a Poisson. In part D, again, we could have used a Poisson distribution here to calculate this probability. Y does have a gamma distribution, but if I have not had, if the second car is towed in before the repair shop opens at 8, it means that the number of events that occurred in 8 hours is at least 2. So I could use a Poisson with lambda equal to 6.5 over 3. That would be the number of events I'd expect in 8 hours. And then take 1 minus the probability that it'd have 0 events minus the probability that it'd have 1 event, which should give me 1 minus e to the minus 6.5 over 3 minus 6.5 over 3 times e to the minus 6.5 over 3. And lo and behold, it would give us the same answer. So again, 2 different ways that you could calculate those probabilities, one using the Poisson and one using the gamma. Okay, and coming into the last part of the question, on average, how many cars are towed in before the repair shop opens at 8 o'clock? Keep in mind that's our gamma distribution. So we're really looking for sort of our expected value of y here. Sorry, wait a minute. On average, how many cars are towed in before the... Okay, no, expected value is expected time we wait. So this is the expected number of cars that would be towed in. So if we have 6.5 per 24 hours, and we want to know... multiply that by 8 hours, we would expect about 2.167 to be towed in during the first 8 hours. Because this will tell me how many per hour. We've got 8 hours, so 1/3 of that is going to be my expected number in 8 hours, because that's 1/3 of a day. And there's our answer to question 8.